6-3 additional practice, page 33, 34, and in practice, we're working on turns called rotations. We're talking 90 degree, 180 degree, 270 degree rotations around a certain point. And we call that a fixed point. Here we go. What is the angle rotation about the origin? Okay, that's our fixed point. Okay, that maps triangle PQR to the image of triangle PQR. Pre-image, image. Okay. Now I know Mr. Fricke in the lesson talked about, hey, just count the quadrants that shape moves through. We always are going to move in a counterclockwise fashion. So we're going from quadrant 1 into quadrant 2. One quadrant. Each quadrant is worth 90 degrees, basically. So what is the angle measurement? It's a 90-degree rotation. That's it. Let's move on. Number 2. Okay, is this a rotation of this? Well, what we have to check and see is it the same size and same shape? Yes. Okay. Now this thing's been turned. Does it have the same orientation? If it's a rotation, it will have the same orientation. So let's look at this figure here. Okay, start at point X and go around. This one goes X, Z, Y. Start at point X. Go around. This one goes X to Z to Y. So is it a rotation? Yeah. Same size, same shape, same orientation. So we're going to say, is it a rotation? Yes. It has same shape, size, and orientation. Bingo. There you go. Okay. Number 3. What is the angle of rotation about the origin that maps quadrilateral PQRS? Again, we're looking for the one that doesn't have those little prime marks. So this is the original. Onto this one. So let's go around. How many quadrants is this shape moving through? This would be quadrant 1, or I'm sorry, this is quadrant 1, but it's going into 1 quadrant, 2 quadrants, 3 quadrants. Each quadrant worth 90 degrees. So you basically take 3 times 90, and 3 times 90 is 270 degrees. That is a 270 degree rotation. Moving down, number 4 says, graph and label this pentagon after 180 degree rotation. Well, 180 degree rotation, if you reference your table in your book with the rules, hey, we take an ordered pair, and to rotate it 180 degrees, all we do is take the opposite of the x value and the opposite of the original y value. Okay? The other way we can think about this is going, hey, we're in quadrant 3 right now. 180 degrees would take us into quadrant number 1. Okay? I know in quadrant 1, every point is going to have a positive x value, positive y value. So these points are going to turn from a negative negative into a positive positive. We don't have to put it in a tumble machine and flip them around. It's just take the opposite of these points. So point J right now is negative 3, negative 2. Image of J, over 3, up 2. There's the image of J. Point K, negative 2, negative 3. All we're doing is taking the opposite. 2, 3. Point, label. That's the image of K. Point L, negative 2, negative 5. Opposite of negative 2, positive 2, opposite of negative 5, positive 5. Bingo. There it is. That is the image of L. Point M, negative 4, negative 5. Go 4, up 5. There we go. That is point M. And then finally point N, negative 4, negative 3. We're going over 4 and up 3. There, my friends, is that shape after 180 degree rotation. Same size, same shape, same orientation. It is just in a new position. Number 5, is this image a 90 degree rotation of this? So if we take this and rotate it 90 degrees, well, let's check. 90 degrees, we're going from here all the way around to there. Okay? We're going through 1 quadrant, 2 quadrant, 3 quadrants. Each quadrant's 90 degrees. So we would take 3 times 90, which is 270 degrees. So is this a 90-degree rotation? No. Explain. It is 270-degree rotation. Boom. Questions? Didn't think so. Okay, next one. Flipping over to the back. It says, hey, we're going to rotate that 270 degrees. So think about it. Right now it's in quadrant 2. 270 degrees. 90, 180, 270. We're going from here all the way around into quadrant number 1. Okay? The rule for a 270-degree rotation, okay, is that we take a coordinate pair. This time we got to put it in the tumble machine. So those 2 numbers are going to flip around, and then we have to take the opposite of one of them. We're going to take the opposite of whatever that x value was. So let's go through these, and I'm going to do some of my writing over here to the right. Hey, this point right here, which is the point -2. This is point t. -2, +3. Well, the image of t is going to, we got to flip them around, 3 and -2. But remember, we have to take the opposite of that x number. So instead of this being negative, now it's going to be positive. Remember, it's got to be, both of these numbers have to be positive on this one because we're ending up in quadrant number 1. So over 3 up 2. There's the image of t. R, which is originally -4, 4. Right? The image of R. Put it in the tumble machine, 4, -4. Take the opposite of this number. Boom. Now it's going to be at 4, 4. There we go. There's the image of R. Last one is I, which is -2, 6. Put it in the tumble machine. 6, -2. But again, we have to take the opposite of that second number. That would produce the point 62 over 6 up 2. Bingo. That's the image of I. Connect the points. We just rotated at 270 degrees. Next up, moving on down, we're going to jump down to number 8. And we've got these 2 rectangles. Part A. Now, this is pre-image. This is image. What is the angle of rotation about that maps quadrilateral WXYZ, which is this, onto this? That sure looks like we're only rotating 1 quadrant. 1 quadrant takes us where? 90 degrees. Okay? That's a 90-degree rotation. Part B, what changes when mapping? What is the one thing that changes when mapping a pre-image, boom, to the image? Boom. What's the one thing that changes? Does the size change? No. Shape? No. Position? Is that in a new spot? Absolutely. Right? The position changes. So there is your additional practice, page 33, 34 on rotations. Good luck on the Math Excel. Enjoy your